Good morning or good afternoon, whatever your case may be. My name is Bill Murphy. I am the civil engineer for Bowman Construction Supply, as well as ASP Enterprises, Quick Supply Company, and most recently, Cascade Geo. And I'm joined by a couple of speakers. I don't have their picture on this screen, but hopefully everybody can hear me okay. And I'll ask the other speakers to mute their phones and close out of any other apps that they're in. While I'm hosting this presentation on my computer, we will be sharing controls back and forth. So we'll have two primary speakers, the first of which will be Tom Bowman II. He is the president of Rocky Mountain Bioproducts, a division of Bowman Construction Supply. Tom has been involved in the ecological restoration, erosion, and sediment control in mine reclamation industries for over 19 years. He works closely with landscape architects, engineers, federal and state and local government agencies, U.S. Forest Service, the Bureau of Land Management, EPA, mine managers, and independent consultants on their reclamation projects. He also assists in value engineering solutions for projects, focusing his efforts on building healthy soils for natural plant growth and long-term establishment for long-lasting results. Using the right products for the right projects is important for vegetation success. He is always willing to make site inspections to help customers or participate in turf inspections. And as a civil engineer, I can tell you I'm not an expert on soil or plants. I did have to learn a little bit about it for soil for foundations, but not with vegetation in mind. So I'm really grateful, so are other civil engineers, to have a vegetation expert. And I'm going to go ahead and give the bio for our second speaker, William Agnew of Agnew Environmental Consulting, LLC. William Agnew is the owner of Agnew Environmental Consulting, a small firm specializing in vegetation selection, management, establishment, and soils evaluation and enhancement, erosion control, water quality, mitigation, and land management strategies for the seed, mining, energy, utility, erosion control, and reclamation industries. William has a BS in wildlife biology and a master's in range management, both from Colorado State University. William is a CPASC and is responsible for and contributed to over 25 professional publications. Grateful to have them both with us. I'm going to go ahead and hand over controls because I did not put in any introductory slides for our companies, because the companies that I mentioned are across several states. I want to focus your attention on the topic today, vegetation management, organic fertilizers, and soil amendments. So I'm going to go ahead and hand over controls to Tom Bowman. You're our first speaker, correct?
Yep, you got it. That's right, Bill.
Feel free to speak up a little bit or move your mic or your jabra closer to you, and then you are good to go, sir. Thank you.
All right, thank you. Thanks for the introduction, and welcome everybody. Thank you for taking time out of your day to be here. I know that in today's world, we're all getting bombarded with webinars, Zoom meetings, team meetings, whatever it takes. But anyway, I appreciate you guys all taking time to attend today's session and listen in. Hopefully, we can gain some value out of this for you. And I urge you guys to put your questions down and send us your questions in, and we will address those at the end of the talk.
So, Tom, this is Bill. Murphy, can I chime in with you? I'm glad you said that. We disabled the chat function on this, but there is a Q&A available for them on this program. So. Okay. If they could use that question and answer, they could type those questions into us. If we have time at the end, we'll let you and Bill Agnew, let our experts answer those. And if we don't have time to get to those, we can follow up with an email, and everybody will get the same email with all of the answers to all of their questions.
Perfect. Perfect. Yep. And we plan to have this presentation done in about 45 to 50 minutes so that everyone does have some time for some questions, and or you can at least we're not taking up a full hour of your time. So with that said, vegetation management is a critical issue in reclamation, obviously. It is reclaiming soils, and in mines and oil and gas pads, it is key. And for getting bonds released and money back to our contractors. So with that said, Bill, I am not able to move my screen.
Yes, because I clicked on the screen and moved my mouse. You're gonna have to click back in the screen again. Every time I bump my mouse, it takes it away from you. Sorry about that. Try it again. If you click in the screen, it should advance. There you go.
There we go.
You're going fast now.
Awesome. Thank you.
So everybody's paying attention.
Yeah. So we're going to talk about soils, organics, fertilizers, and soil amendments. We'll touch upon all of this today. So, wow, you're not kidding. You're going fast. Okay. So what is soil? I think this is pretty common for all of us to know, but we like to talk about organic matter, those numbers being between 3 and 5%. Minerals and your trace elements are obviously key for getting these plants to start surviving and to establish and for long-term growth. Water, air, microorganisms, again, a key element that a lot of people don't pay attention to, but they are a key element to that. They drive the soil life. So when we look at soils around the world or around the United States, you can take a look on that map and find out where you are. But you know, for these people that are in places like California, Nevada, Arizona, New Mexico, Colorado especially too, you know, there's a wide range of soils. 12 dominant soil classifications, but out of those, there's over 70,000 different types of soils in the United States. So it's important to know that and understand that we're dealing with all types of soils. With that said, I'm going to turn this presentation, this part of the presentation, over to Bill Agnew.
Hey, thank you, guys. Appreciate it. And Tom had just alluded to the fact from a soils perspective, vegetation, similarly, this is a level-free ecoregion map of the United States. And, you know, you look back at, let me see here if I can. Again, I'm locked, Bill.
Oh, I just, from Tom handing over to you, I just took over controls and sent them to you. If you click on the screen, it's going to be all yours.
Okay, I got it.
You bet.
Okay, as mentioned, vegetation, you can see that the soils map, sorry about that, but the soils map, and then there's the vegetation map. There's some similarities, obvious similarities between native plant communities and dominant vegetation soil types. Certain soils, sandy soils, you get different types of vegetation growing on those areas compared to areas with heavier soils or more clay type soils. So when you look at the vegetation, and again, what we're dealing with is vegetation as really the primary solution to mitigate and get get compliance associated with your project. So why do you want vegetation, first off? And I think there's some potential problems associated with getting vegetation established, or if you don't get vegetation established. In this particular case, you can see that area that you see within the roadside was actually seeded, but you can see that a great stand of vegetation at the toe of the slope, but essentially all of the seed washed off of that. So that slope. So as a consequence of that, what do you end up with? You end up with water quality type of problems. So that's imperative that vegetation become established, not only from a compliance perspective, but also from a water quality and a soil stabilization standpoint. So what do you have? So there's some basic environmental requirements for seed germination and establishment, right? I mean, you need to have viable seed, first off. You need sunlight, moisture, soil temperature, oxygen, and you need a soil platform. And that's really what we're talking about today, that soil platform. In mining situations, oftentimes you flip-flop the topography and the soil type, or at least the growth medium that you have on the surface, is sometimes not very conducive to vegetation establishment and plant growth. So anytime that you can add soil growth medium, be it topsoil or other fertility types of measures, you're always going to end up with a better end product. So in addition to that, some of the basics from a seeding perspective. Typically, most of you deal with pure live seed, right? Okay, so pure live seed is the PLS factor there. So when you're specifying seed, it's really important that you identify your needs on a pure live seed basis. To give you an example, most grasses have a fairly high purity and germination, so they have a high PLS factor, which would be, let's use example of 90% pure and 90% germination, so the PLS factor would be 81. What you're doing, it's a multiple of those, so you're elevating the amount of bulk seed to get a PLS factor. So PLS is really important, particularly when you're dealing with woody plants, shrubs. Sagebrush in particular might be a good example. You want to require your seed supply. If there's ever any questions that you have concerning seed, you can always request your seed supplier and actual laboratory seed results, looking at the purity, the germination, the inert, any weeds that might be in there. That's important information and is always available to you as an end user from your seed supplier. You want to deliver seed maybe in a single bag if there's any concerns you have, or most oftentimes you end up ordering your seed in mixes. You get, if there's substitutions that are needed, sometimes other companies may have a particular species. So maybe you want to check other seed companies regarding seed availability, and then they have any substitutions, required seed that you have to have in your seed mix. And then from an erosion control standpoint, your erosion control materials really need to have a functional longevity, at least ideally anyway, the first growing season of the plants. The erosion control materials, the function of those essentially go dormant as the plant materials start to come on board and those erosion control materials degrade. And you have considerable performance based on, you can consider performance-based specifications. And if there's questions that you have about your seed or your plant materials in your area, you can always contact local professionals for specifications, which would include other seed companies. So looking at seed basics again, perennial versus annual plant materials in a seed mixture. Perennials are plants that come up every year from the individual mother plant. They take longer to develop. They put more energy into the root systems. They might not germinate for months. They may stay dormant in the soil profile. They provide long-term erosion protection. They require a slower nitrogen release. Some work, and most work pretty well. Some don't. They're tough materials. Annuals come up fairly quickly. They're fairly short-lived. They reseed, some don't. You have sterile materials that are in the marketplace that can come up and provide erosion protection, soil coverage, but they don't shatter viable seed on the soil surface. So you can, and some of sometimes an annual might crowd out your perennials if it's too aggressive. You can create weedy type problems, and it provide quick erosion protection is what annuals do. So there's an example looking at the established perennial root system versus an annual root system, considerably more established with a perennial root system over time. Then in summary, vegetation is really the best long-term solution to mitigate erosion, and proper soil fertility significantly enhances the performance of establishing plant materials. So remember, when you're establishing plant materials, the basics of that seed growing, soil growth medium, moisture, the list essentially showed in the previous slide. You want to define the target plant community that you want. Do you want a grass community? Do you want a woody plant community? Those are all things that when you select your plant materials, you can select and put it in at a certain percentage to try to ensure that you don't have, or that you target the long-term plant community that you want, whether it's a grass community or a woody plant community. So you want to look at the best types of plant materials that are available in the marketplace for your restoration or rehabilitation project. Plant guides to establish seeding rates. Realize seed size is a very important factor when selecting plant materials, and particularly when you start specifying the rates of applications. So when you look at something like sand drop seed, you may have 4 or 5 million seeds per pound compared to something like western wheatgrass, or you might have 50,000 seeds per pound. So when you specify rates of applications, you need to know the seed size that you're dealing with. And then you want to strive to balance the soil quality, the erosion control, and the plant selection to reach some sustainable plant growth. You really have to have the soil, you have to be able to provide the soil, the plants with viable with food. The fertility, the fertilizer you're using, essentially the food for the plant that needs. And the biosol is a material that works very well, releasing over a long period of time so the plants can utilize that material. And then you want to inspect your applications and you want to track your field results. And I'll go over to Tom on now.
Thank you, Bill. Okay. I think you'll be good to go there. Thank you, Bill, for the control. So yeah, when we talk about soils, and we love to see, we would never go to a doctor from a human standpoint, go to a doctor and ask him for help without having them see us if we had a rash, if we were sick. So ideally, why would we treat our soils any different when we're on the hook for, or on the line for vegetation growth? So we love to see soil samples.
You need to click on the screen there and you'll have control, Tom Bowman. There you go.
Yep. Oh yeah. Yep. Okay. Thank you. So yeah, soil testing is important to us. So we will do soil tests for you. You can send it in to us. We'll have it analyzed through an individual lab, a private lab, or an independent lab, I should say. Or you can have it, if you've got a lab that you've had it done or you enjoy working with, send it in to us. We can take a look at the results or we'll have it tested for you. So when we look at different soils, you can see different soils. So, you know, many of us may work with that photo that's there on the right. That's a concrete mix. Very rarely do people in the mining industry, or do we ever get that opportunity to have a true topsoil, something that's been salvaged and managed and harvested. So it's important that we look at how we are managing our topsoil. This is a project. This was a Colorado Department of Transportation project. The contractors thought they were doing themselves a great favor by salvaging that topsoil. That is nice that they salvaged what they could, but can you imagine being any microbe in the middle of that thing trying to live? There's nothing on that soil to keep the microbes alive, to keep any soil fertility in there, to keep your mycorrhiza in there. So that's important that we don't salvage our topsoil in such a way. So when we look at products that can be used in mine reclamation, one of the top products that we use is a product called Biosol Forte. Biosol's got a couple different products. It's a plant-based organic fertilizer. That product is comprised of bacterial and fungal biomasses. There's no animal waste. In fact, it is 100% plant material that's gone through a fermentation process. It's the byproduct of penicillin. So when that fermentation process happens with all those plant ingredients or plant materials, it becomes a very slow releasing, long lasting organic fertilizer. So I want you to think of this as if it's kind of, as I equate it to eating grapes or drinking grapes that have been fermented, eating barley and hops or drinking barley and hops that has been fermented. That fermentation process changes the structure of those elements. And that's where that makes this product completely unique and different to anything else on the market. In fact, our bacterial biomass that is put in the Biosol Forte goes through 2 fermentation processes. So again, very long-lasting organic nutrient. So Biosol Forte's got a nutrient value of 721, only 75% of it's organic matter. I want to touch on that for a moment, because when we look at organics, there's 3 types of how we classify as organics. There's organic material, which you can say is compost, and our material, our Biosol Forte, you take manures, or it starts out as 100% organic material. But when we break it down, we come back to organic matter. And that organic matter is what has value to plants and soils for soil life and plant health and plant life. What is the third component of organic is what we would call organic debris. So if we start out with 100% organic matter, or I'm sorry, 100% organic material, And now this product, for example, is 75% organic matter. What's the rest is that organic debris. So we know that organic debris really has no intrinsic value to soils or to plants. It's typically just considered as ash. The uniqueness of this product too is it's going to last for about 3 to 5 years in non-irrigated soils. So what really makes it different? So if we take a look at what's really inside these numbers, and it's important to know that the numbers don't always equal numbers of another product. So a 721 product that may be chemically driven doesn't necessarily mean that the 721 product that from our product, from the Biosol product, is the same. That might be a nutrient issue. They may be the same, but it doesn't tell you the whole story, as Paul Harvey would say, for the rest of the story. So organic matter, or, as I indicated, this is the Biosol products are over 75% organic matter. Okay, organic matter holds and stabilizes soil particles, supports soil and plant life. It increases water holding capacity immensely. 1% of organic matter is the same as 10,000 pounds of organic matter per 1 million pounds of soil. Holds a lot. The other uniqueness of this product is the Biosol will build soil humus 7 times faster than natural succession does. Our fungal biomass in the Biosol. Well, your fungal biomasses are important because they absorb food from dead organic matter. It converts hard to digest organic material into food. It's important for nutrient cycling and water dynamics. And then the bacterial biomass feeds other soil microbes, keeps soil nutrients in the root zone, enhances soil structure. And one of the things that a lot of people don't realize what bacterial biomasses do, filters and breaks down pollutants in the soils. And then really one of the driving forces and uniquenesses of our product is just one of them here is the mycelium. So mycelium is the vegetative part of fungus that supports the development of mycorrhiza. So this is like 1 + 1 in comparison to mycorrhiza, and we'll touch on mycorrhiza here shortly. But it's not equaling 2, it's equaling like 4, 5, and 6. That mycorrhiza is a natural biomass that is naturally reoccurring in healthy soils. And again, that mycelium is the base for the Biosol products. It's the most important and permanent part of fungus. Oops, yeah, a little trigger happy. So chitin is the second unique portion of this product. If you think of chitin, or you think of shellfish, think of when you've gone to get peel and eat shrimp, during a Super Bowl or during your favorite brunch or whatever. You get that, you peel off that shrimp shell, and that shell is basically the equivalent of chitin. That shell is the exoskeleton of fungi. It's a nitrogenous polysaccharide source of nitrogen. So insoluble in water, resistant to decay, yet it's going to take microbes to break it down. And as you can see there on the right, it's kind of got like a porous web-like structure. So great housing unit for microbes, where microbes can slowly make that nutrient available to plants. And we know that this is about where a good portion of the nitrogen in Biosol is coming from. And then we're high in carbon. Again, you see that soil structure there, or that structure on the right. Again, it's like a web. It's like a housing unit for microbes. Biosol's high amount of carbon provides a great place for microbes to live. It's helping release nutrients to plants and promote soil structure. But as I like to say, it's really that housing unit for those microbes to multiply and increase for soil health. So who does the work in the soils? Well, soil microbes. So there's really more than a third there's more in a third of a cup of soil than there are people on the earth. This includes soil fungi, bacteria, worms, nematodes. erosion and fallow soils destroy soil life. And that goes back to that big mound of soil I showed earlier in this presentation. And, you know, trying to keep these microbes alive is key when we salvage topsoil or when we're trying to reestablish these microbes back in the soils. You look at this, you would now understand where I think Star Wars gets some of their characters from. So again, when we apply the Biosol to soil food web, and we're not affecting just plant life, which would be that first trophic level of plants and organic matter. We're adding that bacteria and fungi that's there listed in the second level, which in turn is also feeding our third level of soil. So this is not just a plant nutrient, it's really for soil life and soil health. And again, we look at a study that was done back in 1998. These studies aren't done very often. In fact, we've tried to get these to be done again by numerous people. They don't like doing them. But this is they put all sorts of materials, and you see the list of components they used or materials that they tested. Everything from compost to ammonium phosphate to a blended material like a composted mix to coated sulfur-coated ureas to Biosol. And really the goal of this process was to flush out the nutrients as quickly as possible. So they put it in like a sand column, a sand toilet as I would call it, and they flushed numerous times. They flushed out 10 times to see how quick they could get these products to deplete them from nutrients. Well, you can see your ammonium phosphate was releasing and your composted mix were releasing before they ever really started. The Biosol was a very slow release out of this, was the longest lasting out of this. Now this is a little bit exaggerated because they were forcing water through it. But when they went back to look at this over time, they realized that the Biosol is what mimics what native plants actually want. So again, the Biosol is providing long-term nutrients for over 360 days. That's due to that chitin content. Stimulates and feeds microbial life in the mycorrhiza. That's again from our mycelium and the fungal and bacterial biomasses in the product. Again, it's a long-lasting product because from that fermentation process and the chitin content. Again, it retains moisture. Again, that's due to that chitin content. The one thing this product does not do is does not promote a quick green up. And it's one of the things I like to indicate to people is you can always tell things by the bag. If a bag says reapply it 3 to 4 times a year or 3 to 4 times a growing season, it's not truly a slow release product. So now again, it's just some photos and some kind of some before and after photos to show you guys. This is a MODOT plot, and the interesting part of this, the turkey manure plot on this site had mycorrhiza in it. It's a single species mycorrhiza because when they looked at that soils or that site, it only had 1 species of grasses growing out of the 11 species that were seeded. Creek realignment and restoration project. This is up outside of Helena, Montana. Completely leveled this area, realigned the creek, and this was a drill seeded and then broadcast seeded with Biosol and mycorrhiza. The creek restoration project up in north central Montana. This was an EPA Superfund site. That's it 3 years later. This site's another part of that same similar EPA site. Again, this site was soil pH on this was 1.4 when they started. And again, that's the photo 10 years later. Now this site actually took in some, again, with the soil pH of 1.4, they combined some compost and lime to help neutralize the soils. They did that 6 months prior to seeding, so you did not. They were worried about getting having the soils not being too acidic, obviously, before giving back. So they neutralized it. Here's a pipeline up in Colorado. Army National Guard project up in Guernsey. This was an area that was just getting decimated by the National Guard planes that were flying in and out of there. And then we had Nelk City Slide area. This is up in northern Idaho. This was just a over the night area that slid down across the highway there on your right hand side. You can see how steep it is there on the left. And again, a heavy application rate for us. The contractor insisted on going at 3,000 pounds to the acre. The Federal Highway said that, well, it's going to be a failure. And his point was, why don't we look at it and tell me it's a failure when it fails. This was 1 year later and with tremendously great growth on it. And they've been extremely happy with the way that worked. So I know this is a mine presentation, but I look at this going, boy, our soils have just been eroded off that site. So we're dealing strictly in rock. There we go. I knew I'd have a problem with that. Again, mine reclamation and tailings. And you can see the water, how bad that water was at the bottom of that slope there. And I meant to show that earlier too on that creek realignment project, because you could see the water quality. Again, another site 4 years later. I obviously got some slow internet. I hope this doesn't show on you guys in that way. A repository mine up in Montana. This was a lighter application rate. This is 1,000 pounds to the acre with salvaged topsoil. So again, value engineering the project because they were able to salvage topsoil. So we were able to reduce the amount of material that we had going on the site. Anaconda, this is up on top of on Anaconda. This is a site that was very sandy, very basically it was almost just pure gravel. This is a site that was just flown on. And then the Forest Rose mine again, this was a waste treat area. They did not salvage topsoil, so 2,000 pounds to the acre. And so you can see that we vary our application rates really due to the soil conditions. This is again a top of Anaconda. They went 3,000 pounds in this site, which is funny because there was actually a mistake in their calculations. But when they had done it and they'd spread it out, they said, well, let's take the opportunity to see how 3,000 pounds works. So they got better results with 3,000 pounds than they did with the 1,500 pounds. So, and then lastly, one of our last ones here is New Mexico mine. This was test plots that were literally up at a mine outside of Taos. They were trying to re-veg 2 feet of tailings for this site. And then we've because it's kind of been a sensitive subject in today's world, we're going to touch upon some fire restoration. This was a project done up in outside of Glenwood Springs, Colorado in 2000. One application. After 1 year, 70% of seeds germinated in this severely burned forest fire. And then wetland restoration. As you can see, so a wide range, again, wide range of applications. And again, it comes back down to that, the difference is that those raw materials have gone through fermented processes, makes a, really creating a long-lasting, slow-releasing organic fertilizer. And again, it's that process that makes this product different from other things. And that's, as it makes it different, and it goes through that process, as I touched on earlier, you get the that mycelium is that vegetative source for mycorrhizas. So we know that those two things work hand in hand. Mycorrhiza is the root fungus, myco being fungus, rhiza being roots. So it's a fungus root. They're mutually beneficial relationships, specialized soil fungus and roots. So when it is there to enhance root establishment. Most effective way to get this down is when we can apply it directly with seed. And there, as you see, this, it is truly our below ground connection. If we think of a plant and we only think of what's up top, it might be small, and especially might be small in comparison to what's underground. And there you see, you can see the yellow taproot there coming straight down, and some of the nodes coming off it around the sides, but all that white, those white filaments around those roots is your mycorrhiza. So they're able to dive into smaller soil particles to retrieve water and nutrients. So what's it look like up close? Here's an up close view of it, and kind of a unique perspective here. If you take a look at this, you can see some of these ends and these tips, and it looks like a garden hose. It looks like a hollow opening. Well, that's where the water and nutrients are transferred back and forth into that root and for the plant's use. So what does it do? Well, it releases powerful enzymes into the soil that unlock hard to capture nutrients. It builds its natural microbial system, which greatly enhances plant growth and yields, increases the plant's drought tolerance for environmental extremes, increases root mass by 100 to 1,000 times. So, and it's interesting, when we get a soil analysis, you know, they tell you what's available in the soil. However, many times we know that, you know, like phosphorus is not mobile in soils. So this is where that mycorrhiza is able to go out and retrieve those nutrients from areas away from directly touching the root. And that's what this photo here shows. It also is able to retrieve carbon and attack nutrients or soil debris for nutrients. So as you see these clusters, these little yellow clusters down here in the bottom of this photo, that was this small little pine, and you can see how little that pine is, but that mycorrhiza was going in down and retrieving nutrients off of those pine needles and leaves that were in that soil mix. So really, when we disturb soil, if you disturb the top 3 inches of soil, you've destroyed 55% of the mycorrhizal life in the soil. But once we disturb 9 inches, we've destroyed 97% of that mycorrhizal life in soils. So that's why it's key and elemental to get the mycorrhiza back into a soil, because it's going to be the direct thing that helps those roots establish quicker as well. So here's some before and after photos with and without mycorrhiza. There you see the top plant growth. That's just a turf comparison. So back in 2003, actually, the Federal Highway Department and Forest Service did a test plot. This is the guy who wrote the book on revegetation for the U.S. Forest Service and federal highways. This is what the site looked 7 months after sowing. They used Biosol on the site and mycorrhiza. And then what happened was September the following year, so it's 1 year after sowing, he still had 55% bare soils. And I would tell you, I'd argue that I think that's more than 55% bare soils, but that's what he determined after it. So he called me the following July 2005. Said, Tom, I saw this last year. I think we're gonna have some real problems. I'm a little embarrassed because I've written a book on revegetation. And he goes, but just going to give you a little heads up that we're going to have to make some other recommendations. Well, he called me shortly after he arrived and says, I almost have tears flowing out of my eyes. This is what it looked like a year and a half after it had been sown. And really his message to this was, first of all, there was less than 15% bare soils on many of the sites. But really it comes down to, it takes several years in some cases for native plants to truly express themselves. So give them time. What's interesting is on the other side of this site is basically a vertical wall. This was a site that they'd used 1,800 pounds of Biosol on with some mycorrhiza, high-end tachyphyre. It's reseeded that site 4 times before it gets growing with great germination. This was a vertical wall they seeded right directly across from that previous site. And the gabion walls there were filled with rock, but then they were backfilled some with some fabric and some injected topsoil into those sites. This is just California fescues. So with that said, I'm going to turn this back over to Bill Agnew for Bill to take us through some quantitative data from some fire restoration projects that we've done just recently in California.
Thank you, Tom. Again, this is we're trying to focus on mining activities and the nature of soils when you deal with mine reclamation. Very similarly, in this situation, this is a fire. This was the car fire in Shasta County, Trinity County, California, 2018. Very hot fire. And as a consequence of the fire, a lot of the areas, very high intense burn, essentially destroyed the entire soil growth medium associated with that. So down at least 3 inches or so, it was just a torch situation. So the fire started actually in July 23rd, 2018. It destroyed 1,604 homes. There was it caused over $1 billion, $1.66 billion in damages, and it was very expensive from a suppression standpoint. And it was contained finally in August 30th of 2018, after about 229,000 acres burned. The project itself with the car fire started then in December of 2018 and concluded in April of 2020. So as I'd mentioned, very hot fire essentially scorched the entire soil surface. So soil samples were taken, and it was determined that there was very, very little beneficial growth medium there. So some extreme tactics needed to be taken. And you can see, looking at some of the individual areas, these are homes that were burned. Water quality was a huge issue. There was all these drainages into the Shasta from this fire go into the Sacramento River. And then there was a Chinook salmon that was endangered that come up those tributaries, and they spawn up these small tributaries in Shasta County. So water quality was a huge concern. So that would impact these Chinook salmon. So the State Water Board provided a grant to the Western Shasta Resource Conservation District. And what they did was, the intent was to protect the beneficial uses of the Sacramento River and the tributaries. So a lot of the work that went on with this project was into those small tributaries. And many of them are ephemeral tributaries too. When it starts raining, then in late fall, the water starts filling up in those tributaries, and the salmon actually start spawning up those areas. A lot of the allocated funds, the applications of erosion control materials, high intensity burn slopes, and the primary function was really to get vegetation reestablished in those areas. So that was really the permanent solution, was to get vegetation reestablished. That's what the area looked like before it burned, and that's what the area looked like post-fire. So the materials that were used were native plant materials at 40 pounds per acre rate. Native straw was used in some areas, native straw, native rice straw, and there was also native or rice straw. There was hydraulic hydrostraw BFM that was used in some areas. And then the Biosol. Tom had mentioned that the application rates of Biosol, depending on what you're dealing with and what your cost constraints are, kind of determine what the application rate was. In this particular case, we looked at 400 pounds per acre, and then a mycorrhizal inoculum at 20 pounds per acre. The application, two different methods. One was a hand broadcast of seed, mycorrhiza, and biosol, and then it was followed by a mulch treatment, as you can see right here. A crew of 15 there was 15 individuals consisted of a crew, and what they could do is 2 to 3 reclaimed acres per day. Very labor intensive and fairly expensive. But that was 4 months following seeding, application of biosol and mycorrhiza on those high intensity burn areas. And only high intensity burn areas were treated in this type of application. So that's 4 months later. There's an area you can see that was not treated versus an area in the background that was treated. So very effective application, and biosol was a huge part of ensuring that the plants could grow properly. Again, another application method was a hydraulic application where seed, mycorrhiza, and biosol forte were applied simultaneously. All of it was in that mix. A crew of 3 could do 6 to 7 acres a day. All material was mixed in a single application, much less strenuous, but a little bit more expensive. And you can see the application of the materials, what it looked like the end of, that was in July, 8 months following application. There were some sediment control plots that were established, as well as cover control plots that were established. And the data revealed that on the straw treatments that first year, and again, this was looked at this in May of 2019. This is 1 year's data. The percent cover on the straw treatment areas was 91%, and that was 7 months following application. On the hydraulic areas, 74%, and the control areas, 33%. You can see the related discharge of solids associated with each of those individual cover percentages. So here's what it looked like untreated, and again, what it looked like post-fire treated. The results, there were 898 acres that were hand treated through the spring of 2020. Hydraulically, 265 acres were treated, but the value of this is really the amount of sediment lost, whether it's on a fire situation or a situation on a reclamation perspective from a mine standpoint. There was nearly 12 times less sediment discharged in those areas for downstream locations when vegetation was established in a very timely fashion and at a high rate of but So the hand-treated areas, there was 12 times. On the hydraulic areas, there was about 4 times the less sediment treated. But overall, there were tens of thousands of tons of sediment that were discharged, that weren't discharged downstream compared to areas that were not treated. So Tom, you take it from here.
Thanks, Bill. Yep. So really, like I said, we didn't want to keep everyone for an hour, but to really wrap this up, who should be using these products and these methods? Really, we look at DOTs, national parks, anyone that's doing any restoration, reclamation. You know, mines we know are up against it the most. We know that they typically have the worst soils. You know, they're doing large projects, not able to salvage enough topsoil most times. Many times we're dealing with abandoned mine lands that was never even a consideration back in the day. So anytime we're looking at doing reclamation, as I'm trying to move forward.
So I took over the handoff there between Agnew and you, so you should have it now, Tom Bowman.
Okay. So really, we look at this as, you know, your dirt, your site, your problem, but our biosolution for your peace of mind. It's we hope that we're able to work with many of you and help you, guide you to maybe one of our distributors to to help you as well. We've got locations around the country and distributors around the country. So what happens with poor soil prep? Well, and poor organic material, you typically get a fail. So with that said, I want to thank everyone for attending today. Like I said, got this thing over in about 50 minutes so that we're not taking a full hour of everyone's time. Love to have questions or emails. If you've got the time, there's our information there on the bottom. So you can always feel free to email us. The website's there on the bottom. And Bill, I don't know if we have any questions or not.
I don't see any written questions, but I have one for both of you. And this would be on a typical project, if someone was to say, okay, we've got a mine and we've in the past dealt with some local folks and we've done some things that had mixed results, but we're really looking to step up our efforts. I assume their first step would be to call one of you or email one of you, but kind of talk us through or walk us through what that would look like once they contact you, all the way through the fact of ordering, once you make a recommendation, ordering product, having product delivered and having that applied. What does that look like?
Great question. Yeah, and so I go back to we ideally love to see the soil samples, because again, that tells us what's going on. You know, we can look at soil and many times, whether it's sand or topsoil, anything in between, clay, we can have a little bit of an idea of what's going on or what type it might be. But if we can get a better handle as to what's really going on within that soil as far as nutrients, micronutrients, organic matter, the salt level, salt and sodium contents of that soil are element to us. So ideally a soil sample. Like I said earlier, you can send us the soil, we'll have it tested, we'll send you the results back with a recommendation. Or you can send us that soil sample analysis that you had done from a friend or from another lab. We look at a wide variety of elements in that first. Two is we will then put pen to paper on that and walk through with an engineer, a mine manager, as far as a recommendation and budgets, and say, you know, there's many ways we can alter this a little bit. We can value engineer it to fit within a contractor or mine's budget. And then lastly, when we ship material, it either comes in 50-pound bags or 1-ton bags, depending upon the contractor's situation as to what they can handle, what kind of equipment they have on site, and then we can just ship it. We have shipped material to staging areas, offices, to mile markers. So really, it's a pretty convenient process. And in many ways, the other advantage of this is we can customize it by, when we look at those soil samples, we can customize things for your sites. So we're not trying to tell you, you got to take everything out of one bag, no matter what. That would be my comment. And I don't know if Bill Agnew would have anything to add to that, or?
You know, just to add to that, you know, there's also some assistance from a native plant material standpoint or best plant materials available that could help you on developing or establishing on your site. So, you know, if we can't answer those questions, we can direct you to the individuals that can answer those questions. So.
And lastly, one other thing I'm trying is these are products that are, the nice thing about these is you can broadcast it, you can throw it through a hydro seeder. They've been hand done, or they've been dropped out of a helicopter. So we really don't have a limitation on applications of it. There are other products out there that that have to go through a hydro seeder. That's one of the uniquenesses of this product is we're versatile enough to help a wide variety of sites and applications.
You know, and I think it's important to note too that the application of the product can be around water bodies too, without fear that you're going to cause contamination into those water bodies. So that's really an important factor too in utilizing these the plant-based type product.
We've got a written question that's got a lot of parts to it. Thank you both for answering my question. We're at 124, about to be 125. So some other people may not stay on, but gentlemen, it's up to you if you want to answer all of this live. I'll read these parts to you. It's in the Q&A from Rebecca Mann. The first is, why and how does the fermentation process improve nutrient availability? And just before you answer that, we can answer this in writing back to everyone that attended. So we see that we have the contact list of everyone that attended this webinar. We can send out an email to everyone with the written answers. But why and how does the fermentation process improve nutrient availability?
Good question. So that fermentation process is what it does is it doesn't improve nutrient availability. It improves the longevity of the nutrient. Rebecca, that's a great question, and hopefully it's something that's not misleading. So when our initial ingredients, our plant material, goes through that fermentation process, it organically binds it from that fermentation process. So it makes that nutrient more stable and longer lasting. And then that availability is happening because of water and microbial activity and soil temperatures in the soils. That's how that will make that available. Bill, I pulled that question up too. I can read the next one.
Okay.
Where do you recommend purchasing mycorrhiza? And is it always recommended to apply mycorrhiza with Biosol? I would tell you, first, where will you purchase it? Typically through a distributor. There are not many people, there's a lot of places to buy mycorrhiza. There's not many people that produce it, that grow it. I think that you want to make sure as to where you're getting it from. With that said, you don't always have to apply it with Biosol. Mycorrhiza is one of the biggest uses of mycorrhiza is in agriculture, where it can be drill seeded with their ag seed, agricultural seed. And that's one of the beauties of this is, again, an area where you can customize it. We can use less mycorrhiza when we can drill seed it down with seed rather than broadcasting it out. Again, that value engineering. What are the actual sources of organic matter? You mentioned ash. What else? Well, organic matter is your components. Like I said, you start with organic material. Your organic, that's in raw form before it's been composted, before it's been cured or matured. What is left is your organic matter, which is your stable part of the organic material. Your organic matter is what's giving, driving that life too in the soils. That's the stable organics in the soil. And then the ash is just, like I said, is the organic debris. And I think we've shared some of the data from summaries for controlled. You can also see a lot of research on the wefixdirt.com site. And then could you provide a small amount allotment for a research project? Absolutely. So Rebecca, I'd tell you if you're on, and we'll apply this or reach out to you as well, but feel free to let us know what you're looking to do on a research project. We're always happy to be involved in research, kind of what drives this industry and makes us all better. And that's really why we do this, is to make us all better and to make people more successful on their projects.
Well, Rebecca says enthusiastically, thank you for addressing my questions with a smiley face. And I say, thank you, Rebecca. These are always so much better if we get audience participation. So thank you for asking questions, Rebecca. Thank you, Tom, for answering those. We are at 129. So gentlemen, I think we're good, and everyone has your contact information. If they have follow-up questions, they can reach out to you or visit wefixdirt.com.
Thank you,
Awesome.
folks, for participating.
Yep. Thank you, everyone, for taking your time to listen.